Yeah. So today we are going to start the new chapter, heights and distances, right? Okay. Now, so in this, the very first thing which we should know is the line of sight. Okay. The line of sight. What is the line of sight? Means it is, you can say, a line from where, we are looking to some tower or some building, right? Okay. So that is the line of sight, right? You can say when an observer is looking from a point O, suppose from a point O at any point P, then we can say that OP will be the line of sight. Getting that? Okay. So write down. When an observer looks from a point O at an object P, okay, is looking from point O to an object P, then the line OP is called the line of sight. Okay. Right. Now, where is the point P is located? On the basis of that, there is some angle of elevation. Okay. And what is this angle of elevation is? Angle of elevation is either above the level of your eye or below the level of your eye. Getting that? Okay. So let's see. Just write down the heading. Angle of elevation. Angle of elevation. Right. So suppose this is the horizontal line and this is the line of sight, right? Suppose this is the point P. This is the point P. Okay, this is the point P. And you can say this is the horizontal line.
I'm Rakshit. I will be joining a bit late.
Okay. This is point O. Okay. This is the line of sight. Right? As I explained you, if observer is point at O and P and it is looking, this observer is looking at to point P, then the line joining O and P will be the line of sight. Getting that? So OP is the line of sight and OX is the horizontal line. Getting that? Okay. Now, if suppose you are at point O, okay, you are here or at the point O, right? And you look up at an object P, right? So there is an object which is at the point P and you are looking to this object from the point O, right? And this object P is placed above the level of your eye, right? So what is the level of your eye? That horizontal line, this is the level of your eye, right? But object is placed here. Getting that? The P is the object, right? Okay. Then the angle which the line of sight makes with the horizontal line. So you can see here, there is an angle which is made by this line of sight, OP, with the horizontal line, right? So this horizontal line is the level of the eye, right? Okay. So because the object P is here, it is located above the level of your eye. So you need to see with this with some angle, right? So this angle is called angle of elevation. Is that clear? Okay. So what is that? What is the angle of elevation? So write down. Okay. So the angle which the line of sight, the angle which the line of sight makes with the horizontal line through O is called the angle of elevation. Okay. What is this called? Angle of elevation of P as seen from O. Okay. So now in this case, since the object which is placed at the point P is above the level of the eye of the observer, therefore, the angle which this line of sight is making with the horizontal line is called angle of elevation. So this angle is called angle of elevation. Is that clear? Okay. So this is how we can define the angle of elevation. Similarly, we have angle of depression. So put the heading angle of depression. Angle of depression. Now, what is angle of depression? Now, again, if suppose you are at point O here, right? This is the horizontal line. Okay. And the object P, or the object is placed at the point P. Now, the line joining this O and P will be the line of sight. Okay. So this is the line of sight. Line of sight, right? Now, this angle, right? This angle will be called as angle of depression. This angle is called as angle of depression. So what is angle of depression? If you are looking down at an object which is placed below the level of your eye, because now observer is at the point O and object is placed at point P, right? And level of your eye is this horizontal line, right? And this object is placed below the level of the eye, right? It is here, which is below the level of the eye. So now you need to look down at an object P, right? So the angle which the line of sight is making with the horizontal line, this angle is called angle of depression of P as seen from O. Was that clear? Right? So this is how we can define angle of depression. So you can write down the angle which the line of sight makes with the horizontal line through O is called the angle of depression. Okay. So this angle is called depression of P as seen from O. Okay. So why it is angle of depression? Because this object is placed below the line, below the level of the eye of the observer, right? So that's the reason the angle which is formed by in between line of sight and the horizontal line, okay, will be called as angle of depression. So these are the two angles: angle of depression, angle of elevation, and the line of sight, right? Now, in height and distances, we have to solve the questions where there is some tall building, some observer, some object is placed at a building and you are observing from some point, right? So there must be some angle of elevation, right? Sometimes it may be angle of depression, right? So that angle of depression or elevation will be given in the question. That will be your theta. Okay. Now, since generally the tower and the building, they are straight, right? So we can assume that that is a right angle triangle. Now, taking this angle of depression and angle of elevation as theta, we can find out the simple, the different trigonometric ratios like tan theta, right? Cos theta, cot theta, right? So whatever is required, we can use in the questions, right? So let's see how to do the questions, okay? A vertical pole stands on the level ground from a point on the ground, 25 meters away from the foot of the pole. The angle of elevation of its top is found to be 60 degrees. Find the height of the pole. Okay. So now, what is given here? Very first, let's understand the question. So there is a vertical pole which is standing on the ground level, right? And now from a point on the ground, which is 25 meter away, right? From the foot of the pole, the angle of elevation is given here, that is 60 degree. Getting it? Okay. So let's suppose AB is the pole. We can draw a pole here, right? Suppose this is the pole A and B, right? And height of the pole is suppose h meters. Okay. Now there is a point which is away, 25 meter away from the foot of the pole, right? The observer is observing at the top, right? Top of the building, top of the tower, right? And this angle is given here, that is 60 degree, right? Okay. So this point O is 25 meter away from the foot of the pole. Getting that? Okay. So this is the scenario here, right? So angle AOB is 60 degree, right? Now, since this is a right angle triangle, right? Okay. So angle OAB will be 90 degree, right? Because pole is generally straight, right? So we can assume angle A is 90 degree. Now we have to find the value of h, means the height of the pole, right? So we have assumed that AB is equal to h meters, right? Okay. Now from this right triangle AOB, because this is a right angle triangle, right? From right triangle AOB, right? We know that tan theta is perpendicular upon base. Getting that? So here, what is your theta? That is the angle of elevation, 60 degree. So tan 60 degrees perpendicular over base. What is your perpendicular here? AB is the perpendicular, right? And base is OA. Getting that? Base is OA, right? So write down. AB is H, OA is 25. And what is tan 60 degree? Tan 60 degree is, if you know, in the trigonometry we have done this, right? Tan 60 degree is root 3, right? Tan 60 degree is root 3, right? Okay. So write down tan 60 degree is root 3. Okay. So now we have put the value here. So h will be equal to 25 into root 3, right? Now to find the values in decimals, you can put the value of root 3, which is given in the question, that is approximately 1.732, right? Okay. Now you can multiply this to get the value of h, means the length of the pole, that is 43.3 meters. Okay. So therefore, the height of the pole AB is 43.3 meters, right? So in this way, by using the trigonometric ratio, we have found out the height of the pole. Okay, so please. Now look at this question number 2. Another type of question in this. The length of a string between a kite and a point on the ground is 85 meter. Okay. If the string makes an angle of theta with the ground such that tan theta is 15 upon 8, then find the height of the kite from the ground, assuming that there is no slack in the string, right? So there is a kite, right? And the length of the string between the kite and the point of the ground is 85 meters, right? So very first we will draw the diagram, right? Okay, as it is given that there is no slack in the string, right? Okay, so we can draw it straight, right? Suppose this is the string, okay? A is the position of the kite, right? And this is the length of a string from O to A, which is at the ground, okay? This is the vertical height of the kite from the ground, right? So the length of the string is given here 85 meters, right? This is theta, okay? And this is the perpendicular distance from the ground. The angle is 90 degree, right? So now what is given here? First write down. So we can say that here OX is the horizontal ground, right? This is the horizontal ground. right? A is the position of kite. Okay. And O is the position of the observer, right? Okay. So OA, the length of the string, which is given here, 85 meter, right? Okay. AB is perpendicular over OX, perpendicular distance, right? Now angle BOA is theta, that is the angle of elevation, such that, it is given in the question, such that tan theta is equals to 15 upon 8. This is already given, right? And since AB is perpendicular over AX, right? OX, so we can say that angle OBA is 90 degrees, right? Okay. So now what we have to find? We have to find the height of the kite from the ground. It means we have to find this h. Okay, suppose h is the height of the kite from the ground. Okay. So let A be height of kite from ground is suppose h meters. Right? Okay. Now since this is a right angle triangle, so from right angle triangle ABC, what we have? Sine theta. What is sine theta? Perpendicular upon hypotenuse, right? Okay, perpendicular upon hypotenuse. What is perpendicular here? AB is the perpendicular length and OA is the hypotenuse, right? So write down AB upon OA, right? Okay, getting it? Okay. Now since tan theta, what is tan theta? Tan theta is already given 15 upon 8, right? Okay. 15 upon 8 means this is perpendicular and this is the base. Is that clear? Okay. That means yes or no, right? 15 upon 8. So from here, can you say that sine theta will be, if this is 8 and this is 15, right? So if you make a right angle triangle in which you have perpendicular is 15 and the base is 8, then what will be the length of the hypotenuse? This is 15, this is 8. Then what is this number? Can you tell me? Square root of 289, right? That is 17. So 8, 15 and 17. 8, 15 and 17 are making a Pythagorean triplet. Getting that? Okay. So can we say that sine theta will be is equals to perpendicular upon hypotenuse means 15 upon 17? Getting that? Right? Because this is a ratio. Okay. So here we can put this sine theta as 15 upon 17 because the ratio is always remain same. Right? Okay. So write down. So you can write down sine theta is equals to AB upon OA. This is 15 upon 17 will be equals to AB. What is AB? AB is 85 meter, right? This is 85. Okay. And OA is H according to it. Okay. Is that clear? Yeah. Please correct this. This is AB is not 85. AB is H, which we have to find. And OA is 85, right? Okay. This is AB and this is OA, right? 85 centimeters, 85 meters. Now, we have to find the height of the kite from the ground. So this will be 15 into 85 upon 70. Is that clear? Okay. So this is now 5, right? We can get this. And therefore, we can find out the value of H. That is 15 into 5. That is 75 meters. Is that clear? So in this way, we have got the height of the kite from the ground, right? So write down, therefore, the height of the kite from the ground is 75 meters. Okay, and this is your answer, right? So in this way, we have got the height of the kite from the ground. Now you can note it down. Now look at this question number 3. If a 1.5 meter tall girl stands at a distance of 3 meters from a lamppost and casts a shadow of length 4.5 meter on the ground, find the height of the lamppost. Okay, right? So let's first draw a diagram according to the case given here. So suppose there is a girl, right? And the height of the girl is 1.5 meter. The girl is standing here, like here, along the line CD, and the height of the girl is 1.5 meter, right? And this girl is standing 3 meter from the lamppost, right? That means the distance of the girl means the line CD from the line AB, right? Okay, AB is your lamppost, okay? The height of the lamppost is suppose H, and this girl is standing from the lamppost, which is 3 meter away, right? So this is the distance AC is 3 meter, right? And the cast a shadow of length 4.5 meter, right? Means the shadow of this 1.5 meter tall girl means the shadow of the CD is here. This is CE. CE is the shadow of CD, and this is how much? This is 4.5 meters. Okay, this is suppose 4.5 meters, right, on the ground. Now what we have to find? We have to find the height of the lamppost, right? So suppose we have taken H is the height of the lamppost, right? Okay, so write down what is given to you. Let AB is the lamppost of height H. Okay, H meters, right? Now CD be the girl, okay, and casting shadow, that is CE, okay, right? So CD is given in the question 1.5 meter, that is the height of the girl. CE is the length of the shadow cast on the ground, right? Shadow of the girl, right? And AC, the distance of the girl from the lamppost is 3 meters, right? So this much is given, and we have assumed that the height of the lamppost AB is H meters, and we have to find this H. Now, look at these two triangles. Can you see the triangles? Two triangles, right? In triangle AEB and triangle CED. Triangle AED and triangle CED, right? The bigger one and the smaller one, right? These are similar triangles, right? They are similar triangles. So since they are similar triangles, can we say that the ratio of their lengths will also be same, right? AB upon AE will be equal to CD upon CE, right? Okay, the similarity property, right? AB upon AE, AB upon AE is equals to CD upon CE. The corresponding height, the ratio of the corresponding height will be same. That means, now what is AB? AB is H. What is AE? AE is 3.3 meter plus 4.5 meter, right? This is the length of AE. So 3 plus 4.5, right? This is equal to CD. What is CD? CD is the height of the girl, that is 1.5 meter. And CE is the height of the shadow, which is 4.5 meters, right? So we have equate that their ratios are equal, right? Now we can simplify this. So this will become 1 by 3, right? So now H is equals to 1 by 3 into, now 3 plus 4.5 will become 7.5, right? Now this can be cut, and this is 2.5. So in this way, we have got the height of the lamppost, that is 2.5 meters, right? So using height and distances, right? Using similarity theorem, right? We have found it out that the height of the lamppost is 2.5 meters. So you can write down. Therefore, height of lamppost is 2.5 meters. Is that clear? Now you can note it down. Now, what is sun altitude? Sun altitude. The angle of elevation of the sun from the earth is called sun altitude, right? So write down the angle of elevation of the sun from the earth, okay, is called sun's altitude. Okay, right? So this is sun altitude. Now, this sun altitude is different at the different times of the day, right? Why? Because position of the sun is different at the different times from the earth. Earth is moving around the sun, and there's the reason the altitude of the sun will be different at the different times of the day. So write down the sun's altitude are different at different times of the day. Okay, so altitude will get changed, okay, after some time. Now, let's see a question based on it. Question number 4. Now look at this question, question number 4. A tower is 50-meter high. Its shadow is x meters. Shorter than the sun's altitude is 45 degree than when it is 30 degree. Okay, is shorter when the sun altitude is 45 degree than when it is 30 degree. Now you have to find the value of x, and it is given that root 3 is 1.732. So first understand what is the question about. So here what is given? That there is a tower and the height of the tower is 50 meter. Okay. And these are the two shadows, you can say, right? These are the two shadows when altitude of the sun is 45 degree and 30 degree. Is that clear? Okay. So first we will draw the diagram according to this, right? Now look at here. Suppose PQ. Suppose PQ be the tower, right? And the height of the tower is given here 50 meter, right? PQ is the tower. Okay. Height is 50 meters, so we can say that PQ is equal to 50 meter. Now PA and PB. PA and PB are the shadow. Okay, these are the shadows, right? PA and PB are the shadows. PA and PB beats shadows. Okay, when the altitude of the sun is suppose 45 degree and 30 degree. That means this is 45 degree and this is 30 degree. Okay, 45 degree and 30 degree respectively. Okay, so you can say that angle PAQ is 45 degree, right? Okay, now its angle get changed. PBQ, that is 30 degree. Getting it? Okay, and this angle P means angle BPQ is 90 degree and PQ here is 50 meters, right? Now, what is given here? That its shadow is x meter shorter than the sun's altitude is 45 degree, then it is 30 degree, right? That means it is shorter when it is 30 degree. The altitude is 30 degree, right? Okay, x shorter. That means what is AB? AB will be x meters, right? Is that clear? Because this 50 meter Are you getting it? Okay, so this is shorter, x meter shorter, right? Okay, so you can write down let AB is x meter, right? Now from right angle triangle APQ, right? What is cot theta? Means cot 45 degree. Cot is base upon perpendicular, right? Okay, base is here AP in this triangle. This is the base and this is the perpendicular, right? AP upon PQ, AP upon PQ, getting it, right? Okay, now you can find out the value of AP here, right? The value of AP, right? How? You can write down cot theta. What is cot 45 degree? Cot 45 degree is 1. So 1 is equals to AP upon PQ. PQ is 50, right? So what will be the value of AP now? That is 50 meters, right? Okay. So we have got the value of AP, 50 meters. Okay. Now, from triangle BPQ. Now look at the triangle BPQ, the bigger one, BPQ. Okay. In this, again, cot 30 degree means cot theta. Cot 30 degree is again base upon perpendicular, that is BP upon PQ, right? Is it clear? Cot 30 degree is what? Cot 30 degree is root 3. Okay, this is the value of cot 30 degree. BP, what is BP? BP is this whole line, length of this line, right? Okay. So we have already calculated AP, which is 50, right? So BP is AP plus X, right? And AP is 50. So this will become 50 plus X. Okay. So write down 50 plus X meters upon PQ. PQ is again 50 meters. Is it clear? Okay. So from this, we can say that 50 into root 3 is equals to 50 plus X, right? Now, X can be equal to 50 root 3, 50 root 3 minus 50. Taking 50 common, you can write down this is root 3 minus 1, right? The value of X is 50 root 3 minus 1, right? Now putting the value 50 into 1.732, the value of root 3 1.732 minus 1. So this is equals to 50 into 0.732, right? Now finding the value of X. So X is equals to 36.6. Okay. So what is the value of X? 36.6 meters. And this is how we can get the value. Okay. And this is our answer. Right. So in this way, we can solve the questions using the trigonometric ratios. Right. So this question is based on the sun's altitude, right? Which is change at the different times, right? So the if angle is changing, right, the altitude will also change, right? Please note it down.